Good evening, everybody. Welcome to Cafe Scientifique Silicon Valley. My name is John McIntosh. I work at DepoMed, and along with Roger Whiting, who's in the front, we help run the cafe. To start things off, as always, a really special thanks to SRI for opening the doors to the International Room, making hundreds of cups of coffee, and throwing thousands of biscotti every year at us to keep everybody in good shape. This cafe wouldn't be possible without the generosity of SRI, just donating resources and people's time and the AV staff and everything to make this a really enjoyable event every month. And also thank you for taking time away from a traditional Thanksgiving evening to come hear about hazardous and toxic waste in the Silicon Valley, some of which is, who knows, maybe under us as we speak, around the Silicon Valley and Santa Clara. We always do a survey before we start off. Who here in the audience is attending a cafe for the first time? All right, about 5%, I'm going to guess. It's been interesting. We've seen that kind of trend down over time as the cafe's grown and got more mature. We see more people who are not regulars, but have at least been to a cafe at least once before. Just to let you know, next month, we, after a couple years of personal search, we're going to have a physicist come in and speak about nuclear energy, about the incidents that happened in Japan, about really all kind of questions asked and answered. So it'll be a really good event next week. And as always, as we scour the internet and the kind of local universities and industry looking for new topics and speakers, if you have a speaker that you know of or a topic that you're interested in that you think would be appealing in the cafe environment, send me an email, let me know. We'll do the legwork and try to get somebody up here to address it. Your responses are always greatly appreciated. So I'm going to quit talking and turn this over to Katherine Baylor and Alana Lee from the Environmental Protection Agency and learn about hazardous waste and bits and bytes.
So thank you everyone for joining us tonight, and thanks John for the introduction. Both Kathy and I are excited to present tonight. Both Kathy and I work in for EPA in hazardous waste management. Specifically, for myself, Kathy can introduce herself, but I am a EPA project manager in the Superfund program. So I work with hazardous waste sites, and specifically tonight, what Kathy and I wanted to do is bring a little bit of the legacy of the hazardous waste management here in Silicon Valley, kind of closer to home, bring that information to you, and then have some discussion. What we'd like to invite you to do is, throughout the presentation, if you do have any questions, feel free to raise your hand, and we'll try to answer them as we go. And then afterwards, with time permitting, we have a video on some of the research work that Kathy and I have been working on in some of this field of study. So next, let's see if I can manage this. So just a little bit about EPA. EPA Region 9 is the Pacific Southwest region. It covers the 4 states, California, Nevada, Hawaii, and Arizona. And then also some of our territories. And then as well as 147 tribes. So it's a very large area. Just a little bit about, and we're not going to go into the regulations, but just really quickly on the hazardous waste management and our regulations and laws, is we have 2 in particular. One's the Resource Conservation and Recovery Act, also referred to as RCRA, and that's waste management where we're looking at operating hazardous waste from the beginning, cradle to grave. And then CERCLA, which is the area that I work in, which is also known as the Superfund, is where we're looking at the nation's identifying and cleaning up the nation's most toxic hazardous waste sites. So here is what I tried to do is hone in on the Superfund sites or the national priorities list sites here in the Bay Area. We have 23 specifically in Santa Clara County alone, 26 in the Bay Area, and we are going to focus in on kind of the theme around why so many in this single county. So one of the legacies of Silicon Valley and the high-tech industry is the use of solvents in part of its processing for cleaning chips and in electronics manufacturing. Subsequently, as part of that process, unfortunately, these solvents leaked into the ground via spills or leaking underground storage tanks and solvent lines. And unfortunately, that then contaminated both the soil and the groundwater beneath it. So one of the primary chemicals that we are going to talk about is TCE, or trichloroethene. It is a solvent that's widely used by the industry, including many of these semiconductor and electronics industries here in Silicon Valley. It's used as a cleaning and degreasing agent. It's not a banned chemical, but through use now, we've actually limited its use here in California. But it is used in other products in the nation. So a little bit about TCE. It is a volatile organic chemical, which means that it evaporates readily in air. This information will be important as we later talk about a different exposure pathway than what we've been dealing with. But because of this, because of some of the properties of TCE, it has a low solubility, relatively low solubility, which makes it very persistent in groundwater, which also makes it very difficult to clean up. Being one of the most common contaminants in groundwater, it's present at more than 861 Superfund sites nationwide.
How many Superfund sites are there?
Nationwide, there's over 1,200. I don't know the exact number. Yeah, it's a good number. And here in California, it's present at probably over 80 sites of our Superfund sites. Okay, just in case I miss it. So a little bit of what's new about TCE, and then there's a cousin chemical, perchloroethene or tetrachloroethene, PCE. Is just recently EPA finalized its toxicological health assessment on it. So that was published on our Integrated Risk Information System, or IRIS. For TCE, it was in September of 2011, so we have new information about that as well. And PCE just was, the final assessment was released this past Friday, the 10th, February 10th.
What were the principal changes in this new assessment compared to the previous one?
Oh,
Cancer?
yeah, they're both, well, for TCE, it is a known human carcinogen, but there's, for TCE, the assessment was in the making for over 10 years now. So I wouldn't do it any justice if I tried to capture all the changes, but one of the principal ones is that it's a known human carcinogen. But there's other both cancer and non-cancer effects. TCE, I'm not as familiar with because of the final assessment was just released. So I wanted to give a little bit of a case example, and this typifies what we'd be seeing in the South Bay at some of our sites. And so this is one in particular that I work on in Mountain View. So we have shallow groundwater. The water table is about 5 to 20 feet below ground surface. As you get closer to the San Francisco Bay, you'll notice that the depth of groundwater decreases. Oftentimes, because of these release of the solvents, we see TCE at high concentrations in this shallow groundwater. When we see this and we have a site, what we immediately try to do is remove the sources. So at all these sites that we have in Silicon Valley, we remove the sources primarily by soil excavation, or sometimes we do utilize soil vapor extraction to remove the contaminants. And that's been very successful in doing so. But as far as groundwater cleanup, oftentimes the method, and Kathy will talk about it in more detail, is simply pumping and treating the groundwater. And at these sites, these legacy sites, we've been doing that for over 20 years. What should be noted is, while we're trying to clean up the groundwater to restore the groundwater to its beneficial use, the groundwater, particularly the shallow groundwater, isn't used for drinking or any uses. But again, we're trying to restore it to its potential beneficial use, which could include drinking water. So next, Kathy's going to talk about the type of remedies that we currently have at our site, pumping and treating, as well as alternative technologies that we're looking at cleaning up the groundwater.
Cool, thank you, Alana. So is that, does that sounds good? Okay. Let me go back a couple of slides because there was kind of a nifty slide. Whoops.
Oh, did I miss it?
Yeah, you missed it.
I did miss it.
There we go.
Thanks, Kathy.
Okay, so this shows the change in groundwater concentrations at a site here in Mountain View. This is actually Alana's site, which is, she manages 2 sites, the MEW site, which is essentially here, and then Moffett Field, you recognize, there's the Moffett Runway, and Hangar 1 is, well, went forward on that. Hangar 1 is right about there. And so you can see, we'll run through that video one more time, the plume has changed over the years. The first slide that comes up is in 1987, and it's a bit deceptive. You can see it's sort of cut off. That was basically because we didn't have information on the down gradient end of the plume, but it actually did extend that far in 1987. So the most important thing to know about groundwater is that it is very easy to contaminate, and it's very hard to clean up. And so that's why these cleanups take decades. And people constantly get after, oh, you've been working on this for 20 years and it's still not cleaned up. And that is exactly because of compounds like TCE and similar compounds. They did get into the groundwater here in Silicon Valley back in the early days when waste handling practices were not what they are today. Under our current waste management, the RCRA cradle to grave, chemical compounds are managed from the time that they are manufactured until the time that they are disposed. That's what we mean by our cradle to grave RCRA regulations. But back in the day, these chemical compounds were misused. They got into ground and into soil and groundwater through leaks in pipelines, just spills, general handling. At the military bases, Air Force bases, Navy bases, they used to use TCE to literally wash down the jet engines. And so the TCE just ran off onto the runway and then it got into the ground that way. So that's why we see some of these very large TCE plumes associated with many of our military bases, particularly the Navy and Air Force bases. So this is really a very widespread problem, not only here in California, but nationwide as well. So we're going to go through some of the remedial technology, starting with the one that's been around for many, many years. This is the first technology that we used at a lot of these sites, and for many years it was pretty much the only available technology. Essentially groundwater extraction and treatment, or what we call pump and treat, where you simply pump the groundwater out of the ground, treat it, and then either discharge it or reuse it. So typical treatment for a pump and treat system, there's a variety of options for treating it, but one of the most common is air stripping, followed by carbon adsorption. So in air stripping, with these volatile organic compounds, they actually want to be in the air. So with these air stripping towers, there's a variety of configurations, but these would be examples of a couple of these, basically large vertical closed tanks. And so the groundwater is pumped into the tank, and then air is blown up forced air is blown up through the tank, so that you increase the surface area with the groundwater that's flowing through the tank, and then the chemicals migrate from the groundwater into the air. So then you have this contaminated vapor, and that gets run through the carbon system. So this, where'd my mouse go? Here it is. So this would be the carbon canister right here. And so that would be a carbon polishing step. So the vapors go through carbon, and then the TCE and other contaminants are adsorbed onto the carbon. Then when that carbon, actually a typical system would have 2 carbon canisters in series, so that when one is used up, you can swap that out and then put the back end carbon system, move it to the front. So there's a variety of configurations for that, but then the carbon canisters would typically be sent off-site for regeneration. Okay, so then that was the basic system, and that's actually a system that's still in place. We got a question over here?
What does regeneration entail?
Regeneration is basically heating up the carbon so that the contaminants then move off of the carbon. So what we're moving between the air stripping system is we're moving it from the groundwater into the vapor, then we're moving it from the vapor into the carbon, and then when we regenerate the carbon, we're moving it from the carbon back into the air, and then it just gets thermally destroyed.
How big an area would something like that handle?
How big of an area? That's actually, that particular treatment system was actually fairly small. So this was a treatment system that was operational at the ROMIC facility. This is a corrective action. It's in the RCRA program, and it's in East Palo Alto. How many people are from Santa Clara County? So pretty much everyone. So everyone knows where East Palo Alto is. How many people have heard of ROMIC? How many people have heard of MEW? Okay. So MEW is actually Intel, Fairchild, and Raytheon. But we call it MEW because it's a Superfund site that's bounded by Middlefield, Ellis, and Wissman. So that's how it got the name MEW, Middlefield, Ellis, Wissman. Those are the roads that bound the facility. And the facilities that were operational back in the day were Intel, Raytheon, and Fairchild. Okay, so this is the ROMIC site.
Another
and
one.
this particular,
One more question.
Sorry.
Sorry.
You
I'll
say
do-
that the DEC is destroyed. What exactly do you mean in the regeneration process?
It's
In the air or it's destroyed?
It's thermally oxidized, so it's basically superheated till it breaks apart the bonds. We don't like to use the word incinerator anymore, but that's essentially what it is. Thermal oxidation, that's what it is.
And then, but that's also done off-site. It's
Yes,
sent
it's
to
done
a
off-site, that's not done
facility.
locally. No, there are special facilities for that, and it's very specially contained. Yes?
So, can you give us an idea of like how long one cycle takes to go through that?
Yeah, good question. So let me go through what a cycle would be, and I still didn't answer your question. So this system was actually fairly small, and you can see it just has the one carbon canister, so it's not a very large system. But this actually, when it was operational, was only running about 10 gallons per minute. So that's really small by groundwater standards. A fairly large site, I don't know how many
Oh,
hundreds
yeah,
of gallons.
at MEW, we have 12 separate individual treatment systems that pumps, the groundwater that it gets extracted and then fed into these is over 650 gallons per minute.
650 gallons per
For
minute
that
versus
system.
6 gallons per, or 10 gallons per minute. So it's a completely different system. And I'm sorry, I already forgot your question.
Oh, how long does one cycle?
Oh, how long does one cycle last? So how long does like one carbon canister last?
Say 10 gallons.
Yeah,
Or, I don't know how long.
right, it runs continuously. So these systems run continuously, but then the carbon depends on the site. So if the site is really contaminated, you can run through the carbon pretty quickly, and you might have to swap it out every couple of months. And so if it's very contaminated, you might have the carbon canisters in series. So you'd swap out the front end one that's most contaminated and just move them up the chain, and then send them all off-site at once. Yes?
So the people who created these leaks and these discharges, are they the ones who are paying for this cleanup?
Yes, absolutely.
It's not
That's,
the taxpayer, but it's actually Intel
yeah.
and so on who are actually paying for this work.
Yes, the general rule is the polluter pays. So the companies are on the hook. They certainly are at MEW. Same thing with ROMIC. ROMIC is on the hook for the investigation and remediation. There are some exceptions to that. The Superfund program does deal with abandoned hazardous waste sites. So those are sites that no owner can be found, or the contamination happened so far back in the day, there's nobody that has ownership of it. That's true of some of our mine sites. Some of the mine waste sites go back to the mid-1800s, and no owner can be found now. So some of this is paid for by the taxpayer, but the general rule is the polluter pays. Yes?
Hi, I'd like to know how, the measurement for, like, a tax vapor stripper on a Coe plume, how it's measured. When they're measuring the VOCs in pounds and report to you, how is that measurement? How do they do that exactly?
That's okay. Here's the question. So if people didn't hear the question, when these systems are operating, when these pump and treat systems are operating, the responsible party, the company who's on the hook, usually they're consultants. It's not actually the company in most cases that does the work, but they hire consultants who do the work, who operate the systems, and then they report to the regulatory agencies, whether it's EPA or some of our state counterparts, say in California, Department of Toxic Substances Control, Regional Water Quality Control Board. Every year they'll come up with an annual report and they'll say how many pounds of TCE, as an example in this case, were treated in the treatment system. And so it's, however many hundreds or thousands of pounds. That's done by the water concentration. So they know how many gallons they're treating. So let's say this system is 10 gallons per minute. Let's say it runs continuously, 24 gallons a day. They know what the average concentration is. Well, they should be monitoring it at least monthly and frequently more often than that. So they know what the concentration is in the water. So from that, they determine how many hundreds of thousands of gallons, and then it's basically just doing the math, and that tells you how many pounds were treated.
They actually have it broken down not just TCE, but all the other VOCs that come through and report to you.
Yeah, so the question is,
5-year report.
right, do they only report TCE or do they report all the compounds? It depends on the site.
On the COE.
That one I'm not familiar with. The COE plume?
HP.
Oh, HP? Okay.
Expressway, but it's not all HP's fault.
Yeah, I'm actually,
Commingling of many corporation stuff.
well,
Stanford Research Park.
yeah, and that's common. It depends on what is specific to that site. So it may be that TCE is the dominant compound, and that might be mostly what they report. But at some sites we have multiple compounds, and so,
Sent to a lab, a certified chain of custody lab, and then analyzed or by weight.
yeah, it's not done by weight, it's done by the concentration. So the sample that gets sent to the lab, when they're analyzing the groundwater, for the volatile organic samples, it's only a very small volume, but it's reported in micrograms per liter.
Well, this report that I read
Okay.
was huge. I was just shocked at the 5-year report on the Payson Road.
The size of the report?
Yeah, no, the amount of different compounds.
Okay.
The amount that was removed by the type tag.
Yeah.
Type tag that not C4, but whatever
Okay.
the name is.
Yeah, it adds up. It can be substantial.
May I ask to return to the main body?
Okay, I'm sorry. We're getting a little bit off here. And okay, if people would prefer, we can take questions at the end.
May cover 30 different chemicals.
Right. So typical analysis covers actually the 8260 is the common analytical method that we use, and that covers up to about 45 different compounds. So it depends on the site and what they're required to report. But I think you've got a good suggestion. Let's go ahead and run through this, and we can hold questions for the end. And obviously, there are a lot of sites down here. I'd kind of like to avoid getting into the specifics of sites because if you're talking about MEW or Moffett, Alana can talk about that. I can talk about Romic, but there's 25 other sites here, so we don't want to get too specific here. Okay, so this is what the MEW plume looked like back in 1992. And this doesn't have any numerical values on it. But what you can see here is, in this case, dark blue is bad. So this ISO concentration line is above 1,000. So this dark blue, this area is all above 1,000 micrograms per liter. To put that in context, our drinking water standard for TCE is 5 micrograms per liter. So this was really quite contaminated in 1992. This cutoff plume is a little deceptive here. It's not really cut off. It's actually pretty much continuous. We just sort of get weird contours like this when we get some weird data gaps, or you get a non-detect well here, but the contaminant actually does extend. And then these little square dashed lines here, these are slurry walls. So the slurry walls that MEW were put in back in
86.
86? Okay, so this was
1986.
1986. Okay, so these were some of the earliest Superfund sites, and slurry walls were a common technology used at MEW and several of the other sites, and it's literally a way of walling off the contamination. So the way they build a slurry wall is they actually dig a trench, around 4 sides if you want to make a rectangular box, and then you fill it up with a cement bentonite slurry. And that hardens, and it basically makes a subsurface wall. So the contaminated groundwater doesn't migrate out very fast. It's not completely impermeable, but the idea is to keep the contamination in place. And then down gradient, you would use your pump and treat or other remedial options. So you can see over the course of, from 1992 up until 2009, the contaminant concentrations are looking a lot better. So certainly there's been a lot of improvement at this particular site. There's actually been overall about a 75% reduction in contamination at this site up until from 1992 until 2009. But we're not there yet, because this outer contour here, this is our 5 microgram per liter line out here, the very lightest blue line. So that's our drinking water standard, and it still means all this is still above the drinking water standard. So there's still more work to be done.
So just for perspective, so that the length of this plume is approximately 1.5 miles long and about a half mile wide.